Hello again. So this is the questions and answers on types of chemical reactions. So let us see that first question. The question says, 4 reactions of this type are shown studied at the same temperature. Which is the correct reaction pathway for the reaction that would proceed most rapidly with good yield? Most rapidly means, do I want a high activation energy or a low activation energy? Remember that for A, for example, is the A an exothermic or endothermic? How do I know if something is exo or endo? If the products are higher than the reactants, then it is endo. So A and B represent endothermic reaction. Now, where is the activation energy? The activation energy, we said, is the distance from the reactants to the very top. So an endothermic reaction usually has a high activation energy, so it is not a very rapid or very fast reaction. Exothermic reactions, which are indicated by C and D, the products have energy lower than the reactants. The activation energy is the distance from the reactants to the top. So the one that has lower activation energy means a lower hill to go through. So C has lower activation energy than D. So C would be the one that is faster and give you a good yield. Okay. Some nitrogen dioxide gas was put in a gas syringe. The end of the gas syringe is sealed. A reversible reaction occurs. The reaction reaches equilibrium, and he gives you an equilibrium reaction. The forward reaction is exothermic. Which statement about this reaction is correct? Now notice that this is an equilibrium reaction. The NO2, nitrogen dioxide gas, is dark brown. The N2O4 is light yellow in color, and the forward reaction is exothermic. So let us take a look at this. Now, the first choice I have are A or B. If the gas syringe is placed in cold water or in hot water. Now, in cold water, he's telling me in cold water the color becomes darker, or in hot water the color becomes lighter. Now, which of these are correct? If the forward reaction is exothermic, then if I put it in cold water, will it go forward or backward? We said if the reaction is the forward reaction is exothermic. That means in order to go forward, I need to cool it. So actually, when I put this reaction in cold water, it will tend to go forward or shift to the right. That means it will make more N2O4. And that means the color should become what? The color should become lighter, not darker. Okay, if I put it in hot water, now the forward is exo, and we said increasing the temperature favors endo. That means if I put it in hot water, it will go backward or it will shift to the left. And that means it will make more NO2. So the color will become darker. So both A and B are wrong. Do we understand that? Okay. Now, C and D is talking about if the volume in the gas syringe is increased or if the volume in the gas syringe is decreased. Now, you should know that the volume of a gas is inversely proportional to the pressure. So if I say the volume was increased, that means the pressure was decreased. If the volume is decreased, that means the pressure is increased. So let's take one of them. Let us say if the volume is decreased, which is my choice in D. Volume decreased means increasing temperature, increasing pressure. And if I increase pressure, we said the reaction will go to which side? We said in any reaction, increasing the pressure, the reaction will shift to the side that has less number of molecules. So in this reaction, if I go forward, it gives 1 molecule of N2O4. If it goes backward, it gives 2 molecules of NO2. So increasing the pressure, this reaction that we're talking about should go forward or shift to the right. And that means that the color should become yellow or lighter. So actually, choice D is the correct. Do we understand why? Please think about this again. The reaction pathway diagram below illustrates the energies of the reactants, products, and transition state. Transition state is the state between reactants and products. Doesn't make a difference. Which expression represents activation energy? Again, we said activation energy is what? It's the distance from reactants to the top. And that means, remember that the top, in this case, is more positive value than the reactant. So in this case, it is E1 minus E2. Do we understand that? It is the distance from reactants to the top. So that is E1 minus E2. Okay. The percentage of ammonia obtainable if equilibrium were established during the Haber process is plotted against the operating pressure for two temperatures, 400 degrees centigrade and 500 degrees centigrade. So which diagram correctly represents the two graphs? Well, let's remind ourselves, what is the Haber process? The Haber process was the reaction in which nitrogen plus hydrogen gives ammonia. And we said that the Haber process, which is the reaction to make ammonia, is an exothermic reaction. So when nitrogen and hydrogen join together to form ammonia, this reaction gives out heat. It is exothermic. Now he's saying, what happens to the percentage of ammonia if I change two temperatures? For example, I'm changing from 400 to 500, and at the same time I'm increasing pressure. Let's take each one by one. Now temperature. If I want to go forward, and that means increase the percent ammonia, should I use higher temperature or lower temperature? Well, we said the forward is exo, and to go forward we need to lower the temperature. So I'm looking for a graph in which 400 degrees gives more ammonia than 500 degrees, because as we lower the temperature, the reaction moves forward, so it forms more ammonia. So which graph says we have more ammonia at 400 than at 500? Well, it's either A or C, right? So my choices are A or C. Now let's look at pressure. We said if we increase the pressure, so if the pressure is going from 0 to 10 to 20, will this reaction give more ammonia or less ammonia? Well, let's take a look. We said increasing pressure, the reaction goes to the side with less number of molecules. Now, if I wanted to go forward, it will form 2. If I want to go backward, it will form 1 nitrogen and 3 hydrogen, so that's a total of 4 molecules. So if I wanted to go forward, I need it to go to the side with less molecules. Going to the side with less molecules means I should increase the pressure. Okay? So as I increase the pressure from 0, 10, 20, my percent ammonia should increase. So which graph says that? A or C? No, C says as I go from 0 to 10 to 20, the percent ammonia is going down. No, then my answer is A. Do we understand that? Please think in exactly the same way. Okay, this is the other question. The reaction pathway for a reversible reaction is shown. Which statement is correct? Now, the graph as it is, you should realize that 30 is the activation energy, and it's a plus value. Plus 30 is the activation energy for this reaction. And 50 is the delta H. Now, the delta H is, in this case, because this is an exothermic reaction. How did I know? Because the products have energy less than the reactants. So this 50 value is a negative value. So the delta H is minus 50, and the energy of activation is plus 30. Now, what is he saying? He's saying the activation energy for the reverse. Where's the reverse? Reverse means I'm going backward. Now, going backward means the one that was product is now reactant. And the now that was reactant is product. So this is now the product, this is now the reactant, and the other one is the product. So if I'm going this way, what would be my activation energy? If I'm going that way from here to here, then my activation energy is the distance from this reactant now to the top. So for the reverse reaction, the activation energy is plus 80. So that is correct. Otherwise, let's take a look at the others and see whether they're right or wrong. Number B says the enthalpy change for the forward reaction is plus 30. Enthalpy change is delta H. We said the delta H for the forward reaction is the distance here from the reactant to the product. So the delta H for this reaction should be minus 50. He is telling me it's plus 30. That's wrong. Now, C says it is plus 50. No, it is not plus 50. It is minus 50 because we're going from something higher to something lower. Now, the enthalpy change for the reverse reaction is plus 30. No, the enthalpy change for the reverse reaction is still 50. In this case, it will be plus 50. Okay, so that is why we chose A. Okay, this is a simple one. He says the diagram shows a reaction pathway for an endothermic reaction. Which arrow represents the activation energy for the forward reaction? We said the activation energy is the distance from where to where? From the reactants to the top. So in this case, of course, the activation energy is B, right? Okay. When gaseous iodine is heated with hydrogen at 450, an equilibrium is established, and he's telling me that the forward reaction is exo or endo. He says the forward reaction has a delta H of plus 53. That means the forward reaction is endothermic. Okay, which change of conditions will cause the purple color to become paler? Now, if I want the purple color to become paler, that means I want the reaction to go forward, right? Okay. To go forward, should I decrease pressure or increase pressure? Well, let's see. Pressure, we said, if I increase pressure, it goes to the side with lower number of molecules. Okay, let us take a look at this reaction. If I go forward, it gives how many molecules? It gives 2. If I go backward, it also gives 2. Now, when the number of moles is the same on both sides of the arrow, then pressure has no effect on the point of equilibrium. So whether I increase pressure or decrease pressure, it will not go forward more or go backward or shift to any place. It will not affect the point of equilibrium. So A and C are not the right answer. Okay, so that means I need to change temperature. So if I want to go forward here, we said the forward is endothermic. To go to the side that's endothermic, should I increase the temperature or decrease the temperature? Remember, we said increasing the temperature, the action goes endo. So in this case, I need to increase the temperature in order to go forward, in order to make a colorless solution. Okay, which of these reactions show only reduction? Let's go back and think about the definition of reduction. Well, reduction is what? Reduction is either gain of electrons or loss of oxygen. So, taking a look at this, first of all, you should realize that neither C or D have anything to do with oxidation or reduction. C is a reaction between acid and base, and we said acid and base is what kind of reaction? It's a neutralization reaction, so it's not oxidation, not reduction. What about D? D is what we call a displacement reaction. We said if magnesium reacts with zinc sulfate, it gives zinc plus magnesium sulfate. That means the magnesium pushed the zinc out and sat instead of it. That means the magnesium displaced the zinc. So C and D are totally wrong. So we're looking at A and B. Now you should realize that in B, I have something losing oxygen and the other one gaining oxygen. So the Fe2O3 changed into Fe. So this is reduction. Now, from the CO changed to CO2. That means it gained oxygen. That is oxidation. So this is actually not only reduction, it is a redox reaction. So A is the only one that is only reduction because it only involves gain of electrons. Nothing else happened. Okay, 2 chemical processes are described. During combustion of gasoline. Now, let's remember that the word combustion is burning, and burning, what happens to the energy in burning of something? Energy is given out because we're talking about exothermic. Burning of any fuel is exothermic, so energy is given out. So my answer is A or B. Okay, during electrolysis, energy is, we haven't done electrolysis yet actually, but I will tell you now that electrolysis is the use of an electric current to break down a compound. So I am giving it energy, so this is energy taken in. Okay, diagram represents the reaction pathway for the following reaction. Which statement can be made about the reverse reaction? So I want to go from Y plus Z to W plus X. Now, will that have a larger activation energy or a smaller activation energy? Well, the activation energy for the forward was from W plus X to the top. But now that I'm going backward, it is from Y plus Z to the top. So, of course, the reverse reaction will have a larger activation energy. So, it is either A or B. What will happen to the delta H? Well, it is still, what are we talking about now? If I go forward like this as it is written, it is what type of reaction? It's exo. But if I go backward, then the products which are now W plus X will have more energy, and that means this is now an endothermic, and the endothermic has what kind of delta H? A positive delta H. So my answer is A. When dilute sulfuric acid reacts with aqueous sodium hydroxide, the temperature of the solution increases. Which words describe this reaction? Okay, when the temperature increases, is it exo or endo? We said if the temperature increases, that means that the reaction that is going on in there has given it heat, so giving out heat, that is exo. So that means that we had an exothermic reaction. Remember, when the temperature rises, this is an exothermic reaction. Okay, but we're also reacting sulfuric acid with sodium hydroxide, and you should realize this is acid plus base, so this is also called neutralization reaction. So this reaction is both exothermic and neutralization. Okay, then we go into bond energies. We talked about bond energies, and we said this is a compound, and he writes out the formula of the N2H4. So we need to calculate the bond energies. Again, how do we calculate bond energy? We have 160. Which one is 160? 160 is the NN bond. So I have one NN bond, and that is plus 160. Plus, how many NH bonds in the N2H4? I have 4 of them. So that is 4 times the 390. Okay, so these are the bonds that I'm breaking in the reactants. Now, the bonds that are formed in the product, I have one NN bond, so that is 945, but since this is formed in the product, it has a negative value because we said formation of bonds is exothermic. It releases this amount of energy. Now, plus 2 H2 bonds, so that means I have 2 of the HH bonds, and that means I have 2 times 436. So when you add all of this up, it comes out to be minus 97 kilojoule per mole. Were you able to get that? You should be able to get that. Please concentrate on finding the correct number of bonds for each one. Okay, which statement describes an exothermic reaction? Okay, we said when we have an exothermic reaction, why is the reaction exothermic? We said exothermic means it gives out heat. That means the amount of energy given out when bonds form in the products is more than the amount of energy needed to take in to break the bonds in the reactant. So which of these says that? The energy absorbed for bond breaking is greater? No. If the energy absorbed for bond breaking is greater, then that would be an endothermic. So the B says the energy absorbed for bond breaking is less than the energy released by bond formation. That's the correct one. Okay, so always remember that if a reaction is exothermic, that means it is giving out more than it is taking in. And breaking of bond in the reactants takes in energy. Forming bonds in the products gives out energy. Now, if the one given out is more, that's exo. If the one taken in is more, that is endo. Copper 2 oxide reacts with hydrogen. Which row is correct? Which one is the oxidizing agent? So we said the oxidizing agent is the one that has been reduced. Which one has been reduced? You should realize that the copper oxide lost its oxygen. So the copper oxide is the one that has been reduced. So it is the one that is acting as an oxidizing agent. The reducing agent is the one that has been oxidized. The hydrogen has gained the oxygen. Again, I'm going to remind you, when you're choosing oxidizing or reducing agents, it is one of the reactants, not one of the products. So copper and water are not included in all of this at all. Okay, methane reacts with steam to produce hydrogen and carbon monoxide. The equation for the reaction is shown, and he's saying the reaction is reversible, okay, and the forward is endothermic. Okay, so he says the forward reaction here is endothermic. Now, which changes in temperature and pressure will give you more carbon monoxide? Will increase the yield, means it will give more mass of carbon monoxide. Okay, first of all, that means I need to go forward, and he's saying the forward is endo. So when I want it to go forward, when I want it to go endo, should I raise the temperature or lower the temperature? Increase the temperature. So my answer is C or D. Now I want it to go forward. Now to go forward, it needs to make 3 hydrogens plus 1 CO, that is 4 molecules. If it goes back, it will make 1 methane, 1 water, so that's only 2. So if I want it to go forward, that means I want it to make more molecules, and we said to make more molecules, should I increase the pressure or decrease the pressure? Yes, we should decrease the pressure. Okay. Define in terms of electron transfer the term oxidation. Remember that we had different definitions for oxidation, but he's specific. He wants you to give the definition that involves transfer of electrons, gain of electrons or loss of electrons. So oxidation was which one? Loss of electrons. Explain why positive ions are oxidizing agents. Remember that an oxidizing agent is the one that becomes reduced, and to become reduced, it gains electrons. Positive ions, in order to react, they have to gain electrons, and that is why positive ions are oxidizing agents. Describe the color change you would observe when an alkene is oxidized with acidified potassium manganate. What was the color of potassium manganate? If I react potassium manganate with something, it changes from purple to colorless. Okay? Okay. Germanium is an element in group 4. The electron distribution of a germanium atom is this. Remember that we said when he gives you an electron distribution, all you care about is the final the number of electrons in outer shell. So this is just saying it's in group 4. It has 4 electrons in outer shell. Now it has 2 oxidation states. Remember we said, what is an oxidation state? That is basically the charge on the ion. So he's saying, is the change germanium Cl2 to germanium Cl4 reduction, oxidation, or neither? You know, of course, that germanium Cl2, when I say germanium Cl2, that means I'm talking about germanium with an oxidation state of +2 or a valency of 2. Germanium Cl4 is something that has valency 4 or oxidation number +4. So if I'm changing it from Ge2+ to Ge4+, what is happening to the oxidation number? It's changing from +2 to +4, so that is increasing. So that is oxidation. Why is it oxidation? Because it is increase in oxidation state. When you answer these questions, make sure that you answer all the parts. So he's saying give a reason for your choice, so don't forget to give him a reason for the choice. Okay, iron has 2 oxidation states, +2 and +3. There are 2 possible equations for the redox reaction between iron and bromine. So indicate on the first equation the change, which is oxidation. Again, remember, oxidation is change from what to what? It's change from something with a lower oxidation number to a higher oxidation number. So in this case, which one is oxidation? It's Fe. We said if there is no plus or minus on it, that means its oxidation number is 0. So Fe has an oxidation number of 0. It is changing to Fe2 plus. That means the oxidation number is changing from 0 to +2, and that is oxidation. Now he says give a reason. So you have already chosen from Fe to Fe2 plus, that is oxidation. Why? You can either say because this is loss of electrons, so when Fe loses electrons it becomes extra 2 positives, or because it is increase in oxidation state. Okay? Which substance in the first equation is the reducing agent? Remember, the word reducing agent is the same as reductant. Again, we said reducing agent is the one that has been oxidized. So which one has been oxidized? We just said the Fe has been oxidized, so the Fe is the reducing agent. Okay? Oxidation states of vanadium, and he says indicate on the following equation which reactant is the oxidant. We said oxidant means oxidizing agent. Oxidizing agent is the one that has been reduced, so we're finding out which one has been reduced. Again, when you're choosing oxidizing agent or reducing agent, you're choosing one of the reactants. So your answer is either V3 plus or Zn. Now, oxidant, oxidizing agent, means it has been reduced. What has happened to the V3 plus and the zinc? The V3 plus has changed into V2 plus. That means the oxidation number has gone from +3 to +2. That means it has decreased. That means that the V3 plus has been reduced. It is the oxidant. Remember, oxidant or oxidizing agent is the one that has been reduced. Which change in the following equation is oxidation? Again, oxidation means increase in oxidation number. So in this equation, the V3 plus has gone to 4 plus. The Fe3 plus has gone to 2 plus. So the oxidation is which one? V3 plus to V4 plus, because that is loss of electrons or increase in oxidation number. Remember, either you say loss of electrons or increase in oxidation number. Okay, another question on bond breaking and bond energy. So he gives you a certain equation and he says explain why the forward reaction is exothermic, and we need to complete this table. So let's take this one by one. Now, HH bonds, he's saying each HH bond we need 4, 3, 6. Now, that means that the energy needed to break the 3 bonds is 3 times 4, 3, 6, and that is a positive. So is that endothermic or exothermic? We said breaking up of bonds in reactants is endothermic. Now the NH bond is bonds that are being formed. How many NH bonds again are we forming? Remember, he's saying I have 2 NH3s, and each NH3 has how many NH bonds? Each NH3 has 3 NH bonds times 2, that's 6 times the number that he gives you. Now these are bonds formed in the product, so this is an exothermic reaction and the energy change is in negative. Now to determine whether this reaction is exo or endo, you add up these numbers. Plus 944 plus 1308 minus 2328, reactants in positive, products in negative. Add them all up, the final answer is in negative. That means the reaction is exothermic since energy is lost to the surroundings. Okay? Okay, bond forming is exothermic, bond breaking is endothermic. Explain the difference between exothermic and endothermic reaction. So you should know the definition. Exothermic reaction gives out heat, endothermic reaction takes in heat. Again, another question about bond energies. So use this data in the table to show the following, that the following reaction is exothermic. Okay, let's take them one by one. So we have CH bonds. Let's take a look at this. We have the CH bond. Each CH bond needs 415. Now, how many CH bonds do I have? I have 1, 2, 3, 4, 5, 6 CH bonds. So 6 CH bonds, that is 6 times 415. Plus, I have 1 single bond C. Can you see that I have one single bond between the C's, C single bond C, that is 1, 3, 4, 6, and I have one C double bond C, so I have 1, 6, 10. So I've finished that first reactant plus hydrogen, which is HH, so that is plus 4, 3, 6. So these are the bonds in the reactants that need energy to be broken, all in positives. Okay, the product now. Let us look at the bonds in the product. We said the bonds in the product are being forming, so they give out energy. So this is exothermic, so this is a minus number. So CH bonds do I have? I have 3, 4, 5, 6, 7, 8, so that means 8 times the 415. And then I have 2 C single bond C, so that is 2 times 3, 4, 6. So the overall is minus 130. That means the reaction gives out heat, so it is exothermic. Do we understand how to answer this? Okay. Vanadium oxide is used to catalyze the exothermic reaction between sulfur dioxide and oxygen in the contact process. The rate of this reaction can be increased either by using a catalyst or by increasing the temperature. Now explain why a catalyst is used and not a higher temperature. Remember that he's saying that the forward reaction is exothermic. So this reaction that is written is exothermic. That means going forward, it gives out heat. So if I increase the temperature, will it go forward or go backward? Now, if the forward is exo, that means increasing temperature or using a higher temperature, this will shift the reaction to the left, backward. And that means I will end up with less SO3. That's why I don't use a higher temperature, because higher temperature will favor backward reaction or force the equilibrium to the left, so less SO3 will be formed. Why do I use a catalyst? I use it to speed up the reaction. So a higher temperature favors backward reaction, since that the backward reaction is the endothermic one, so it would lead to lower yield of sulfur trioxide. We use a catalyst to speed up the reaction without affecting the point of equilibrium, so that will speed up the reaction without forcing it to go backward, for example. Okay, ammonia is made by the Haber process, and he gives you the Haber process. The percentage of ammonia in the equilibrium mixture varies with conditions. The conditions actually used are 200 atmospheres and 450 degrees centigrade and an iron catalyst. The original catalyst was platinum, so he's saying now we use an iron catalyst. So just a reason why it was changed to iron. Why is iron more suitable than platinum? You should realize that whenever we mention platinum, you should realize that platinum is more expensive or that iron is cheaper. That's why we use iron. Explain why the highest pressure gives the highest percentage. Now he shows that as we increase the pressure, the percent of ammonia at any of the temperatures increases. Now why is that? Because increasing the pressure will favor which side? It will force the reaction to go to the side that has less number of molecules. Now which one has less number of molecules? The forward to give ammonia. That means increase in pressure favors the forward reaction to give less number of molecules. Okay? Okay, this is another reversible reaction. Carbon monoxide plus chlorine to give something called carbonyl chloride, and it is reversible, and he's telling me that the forward reaction is exothermic. Remember, there is no way for you to write an equation in front of you and from the equation determine whether it's exothermic or endothermic. So he has to tell you whether it's exo or endo. The reaction is catalyzed by carbon within a temperature range of 50 to 150. Now the question is, predict the effect on the yield. Remember that the word yield means the mass of carbonyl chloride, or the amount that is formed of carbonyl chloride, of increasing the pressure. Okay, this reaction, if we said increasing the pressure, that means we said when the pressure increases, the reaction goes to the side with less molecules. So when he's talking about pressure, I count the number of molecules on both sides of the arrow and I determine which one gives less or more number of molecules. So in this reaction that he gives me, going forward will give 1 molecule of COCl2 or 1 mole of COCl2. On the other going backward, it will give 1 CO and 1 Cl2. So that means I have 2 moles of gases. So going forward gives less. So if I predict the effect of increasing the pressure, you know that increasing the pressure will go to the side with less number of molecules. In this case, it will go forward or it will go to the right. So that means it will give more and more of COCl2. So the yield increases. Why? Because increasing the pressure shifts the equilibrium to the right or to the forward reaction to give less number of molecules. Okay, if the temperature is allowed to increase to above 200, a very little carbonyl chloride is formed. This is because the forward reaction is exothermic. He tells me that the forward reaction is exothermic. And you know that when I increase the temperature, the equilibrium shifts to the left or it goes backward, which is endothermic. And that means that I will get less and less of COCl2. So increase in temperature favors the backward reaction or forces the equilibrium or shifts the equilibrium to the left. So lower yield of COCl2. Now he's saying I have reversible reactions can come to equilibrium, and he has 3 examples of equilibrium reactions or reversible reactions. Explain the term equilibrium, and he usually says this question with 2 marks. Now, what is equilibrium? Remember, we said equilibrium means rate of forward reaction equals rate of backward reaction, and concentrations of both reactants and products remain constant. You always have to say both for the 2 marks. Okay, now he's saying the following graphs show how the percentage of products of a reversible reaction at equilibrium could vary with pressure. For each graph, decide whether the percentage of products decreases, increases, or stays the same when the pressure is increased. Then match each graph to one of the above reactions and give a reason for your choice. So this graph that is drawn in front of us, what is it telling me? It's telling me that as I increase pressure, I'm going from 0 to the right, I'm increasing pressure. What happens to the percent product? Well, this reaction tells me that the percent product increases. So the effect on the percentage product increases. Now he's saying match the graph to one of the above reactions. What were the reactions again? These were the 3 reactions we were supposed to do. So I want to choose a reaction in which increase in pressure increases percent products. Okay, let us take a look at the 3 reactions. The first reaction, if I go forward, it gives how many molecules? 2. If I go backward, it gives 2 also. In this kind of reaction, when the number of moles on both sides of the arrow are the same, then remember we said changing pressure will have no effect. Because you know that increasing pressure, the reaction goes to the side with less number of molecules. Where there is no side with less number of molecules, both of them are the same. That means increasing pressure or decreasing pressure will have no effect on that reaction number 1. Do we understand that? Okay, let's take a look at reaction number 2. Now, in reaction number 2, if I go forward, I make 2 molecules. If I go backward, I make 1 of A2 and 3 of B2. That means I make 4 molecules. So in this reaction, if I increase the pressure, what happens to the percent yield? Well, increasing the pressure will go to the side with less number of molecules, which is forward, and that means it will give me more yield. So this is the reaction that I'm looking for. That is because increasing pressure favors forward reaction to give less number of molecules. Okay, what is the next graph? The next graph says when I increase the pressure, what is happening to the percent product? Well, it's a straight line. The percent product is not changing. So the percent product remains the same. So there is no effect when I increase pressure. Now, which reaction are we talking about again? Which reaction did we say if I increase the pressure there is no effect? We said reaction 1, because there is equal number of moles on both sides of the arrow. So there is no side that has less number of moles or more number of moles. Okay, now this reaction, this graph states that as I increase the pressure going from 0 to the right, I increase pressure. What's happening to the percent product? The percent product is decreasing. Now, which reaction are we talking about? Well, let's take a look. We've already chosen reaction 1 and 2. Let's take a look at reaction 3. Now, in reaction 3, Going forward will give total 3 molecules. Going backward will give 2. So if I increase pressure in this reaction, the equilibrium will go to the side with less number of molecules. In this case, it will go backward, and when the reaction goes backward, that means it's forming less of the product. That means the percent product is decreasing. So reaction 3 is the one in which increasing pressure will decrease the percent product. Why? Because increasing pressure favors backward reaction to give less number of molecules. Okay. When antimony chloride is added to water, a faint white precipitate forms and the mixture slowly goes cloudy. So he's giving me a reaction in which if I have SbCl3, it is colorless. If I add water and it goes forward, it forms SbOCl, which is white. If it goes backward, it will form the colorless solution again. Now the question says, explain why after some time the appearance of the mixture remains unchanged. Remember that we said this is a reversible reaction. And what is the definition of reversible reaction? That it can go both forward and backward. It keeps going forward and backward until what? Until it reaches a state of equilibrium. Remember, what was equilibrium? The rate of forward reaction equals rate of backward reaction. So if the reaction mixture remains unchanged, this must mean that the reaction reaches equilibrium. Rate of forward reaction equals rate of backward reaction, and as such the concentration of reactants and products will remain constant, and that is why it will appear as if there is nothing happening. Okay, when a few drops of concentrated hydrochloric acid are added to the mixture, it changes colorless. So just an explanation. Remember, colorless is the backward reaction. Now, to go backward, we said if I want to force the reaction to go backward, I can add more of the products. So what they're doing is they're adding the HCl. This means, or this favors the backward reaction, or this forces the reaction to go to the left, and that is why it forms more SbCl3, which is colorless. So why do we have colorless solution? Because the equilibrium shifts to the right. So just how you could make the colorless solution go cloudy. Now if I want to go forward again, then I can do what? I can add more of water, for example. Then this will force the reaction to go forward. Okay. Now, ammonia is manufactured by the Haber process again. The forward reaction is exothermic, and he's telling me the percentage of ammonia in the equilibrium mixture varies with temperature and pressure. Now, which pairs, A, B, or C, shows correctly how the percentage of ammonia at equilibrium varies with temperature and with pressure? If you remember this reaction, we have many questions about this reaction. The forward is exothermic. That means if I increase temperature, what happens? Well, we said if I increase temperature, it will actually go backward. So the percentage of ammonia should decrease, not increase as graph in A says. So A is wrong because the temperature is wrong, and without even looking at the graph for the pressure. Now let's look at B. Now B also says that as the temperature increases, the percentage of ammonia increases. No. As the temperature increases, the reaction will go backwards, so the percentage ammonia will decrease, not increase. So both A and B are wrong. Let's take a look at C. Now at C, it is saying that as the temperature increases, what is happening to percent ammonia? Yes, it is decreasing. So this one is probably right. Now let's look at the pressure. We said as we increase pressure, remember the equation again? We said, let's go back to the equation. If I go forward, it gives 2 molecules. If I go backward, it gives 4. And that means as I increase pressure, it favors the side with less number of molecules. So it will go forward and it will cause a higher increase in the percentage of ammonia. So these graphs in C are the ones that are correct. Now you're supposed to explain what I just said. Why did we choose that? Because first of all, increase in temperature favors the backward reaction since it is endothermic, so the yield decreases, and that's the first graph. Now the second graph, increase in pressure favors forward to give less number of moles, so the yield would increase with increasing pressure. Okay, so we're at the end of the chapter. Please study the chapter, do the questions, and we'll meet in the next video.